going to cover the introduction to statistics. We just finished a couple lessons on probability. Within statistics, we're going to do this for, I think, 4 lessons. We're first going to talk about analyzing data, and today specifically focus on measures, what are called measures of central tendency, mean, median, and mode. And we're also within analyzing data, we're going to talk about standard deviation, variance, and normal and binomial distributions. Then we're going to talk about how to collect data effectively. Before we do any of that, though, I'm going to introduce statistics just by defining it and talking about some of its uses. So first, let's define it. Statistics is the study of the collection, analysis, presentation, interpretation, and organization of data. So think of it as the math and science of data. How do you get it, and how do you show it, and how do you use it? Statistics is used in almost every field and is actually one of the more useful, and if not the most useful function or area of mathematics taught. It's used in economics. It basically is economics. Think of things like GDP growth, some of the standard things you hear in the news. GDP growth, unemployment rate, inflation. All the measures of economics of how an economy is doing are basically statistical measures. Another example, science. This is you probably used. Experiments. How do you collect data from experiments? And how do you analyze it? Last one I'm going to do is medicine. So you use statistics to tell effectiveness of treatment. How do you know if something's working or not? That's just a couple examples. It's used basically in almost in every field and industry in the world. We're now going to talk about, that's just a quick intro. We're going to talk about some statistical measures, and we're going to start with the most common one, and probably the one you've had before. So these are statistical measures. And the first one, I thought first, statistical measures. Eventually we're going to do a bunch of these, but today we're just going to cover central tendency, mean, median, mode, things like quartiles, range. You've probably heard familiar with some of them, but maybe not all of them. We're going to start with what are called measures of central tendency. And there are 3 main ones. They're all basically determining what is the middle of the data. That's why it's called central. That's middle. The first one is mean, and for each of these I'm going to define it, and then we'll go through some examples. Mean is sometimes called average as well. And it is equal to the sum of the data, adding it up basically, divided by the number of data, pieces of data. So write that down. If you have to pause to write it down, go ahead. Let me give you an example. Let's say I have a data set, and I'm going to use this data set for this whole thing. We'll do a simple one. 1, 2, 2, 4, 6, 8. There's my data set. I collected 6 pieces of data, 1, 2, 2, 4, 6, and 8. So what is the average of that? It is simply, or mean, is equal to 1 plus 2 plus 2 plus 4 plus 6 plus 8. So add all the pieces of data up, and then divide by the number of pieces of data, which in this case is 1, 2, 3, 4, 5, 6, 6. So I get, what is that, 1, that's 3, 5, 9, 15, 23, divided by 6. Let me use a calculator for that. And we get 3.83. That is the average of those numbers. Okay, so that's mean. I'll have you do a couple in a moment as well with a general data set. Then if I want to know, I'm going to do next to median. Median is literally the middle of the data. So you have to do this, to do a median, you have to put it in order. So middle of data in order. I put it in order, but a lot of times your data collect isn't going to be in order, but it's in order. So if you go in the middle, it's going to be the one right in the middle. So count in from the inside, or the out from both ends until you get to the middle, and you'll find there's the 8-1, that's the outside, 6-2, 4-2, oop, the middle's nothing. So the way you calculate it, if it's an even set of data, you average the middle two. If it's an odd set of data, you just take the middle one. So in this case, it's an even set, so it's somewhere between 2 and 4, so you just take the average of 2 and 4. So in this case, the median is equal to 2 plus 4 divided by 2, or 3. So the median doesn't actually even have to be in the data set, neither did the mean. The last one we're talking about is what's called mode. Mode is the most frequently occurring value. The most frequently occurring value. Just the one that shows up the most. So in this case, there are 2 2s, and there's nothing else that's repeated, so it's 2. There doesn't have to be one mode. There could be 2, 3, or 10 even, if they all have the same number of occurrences. In this case, there's just 2. But I could create another data set. For example, 1, 3, 3, 5, 5, 7, 7, 9. In this case, the mode is 3, 5, and 7. It has 3 modes, which is sometimes called trimodal. Okay, so let me give you an example to work through. I'm just going to erase all this, and I'm going to give you an example to do mean, median, mode, and then you can come back and check that you get the right answers. Just going to give you a simple data set. 16, 19, 14, 27, 31, 12. Let's do one more. 60, no, it's just 16. There we go. And let me change one of these so we actually have no, that'll work actually. I have before, 17. That's fine. 16, 19, 14, 27, 31, 17, and 16. Okay, so what I want you to do is first, if you're going to do median, you've got to put them in order. So I want you to reorder that. So that's what I want you to do while you pause. Reorder. Then find the mean, the median, and the mode of this data set. Okay, pause the video there and try it yourself. Okay, if you're back, I'm going to reorder first. Sometimes this is tricky. You go smallest to largest. 14, I usually check them off so I don't miss any. 16, 16, 17, 19, 27, and 31. Now, I'm going to count them and make sure I actually reordered all of them. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Good. Okay, now I'm going to find the mean. The mean is equal to all these added up. And then divide by the number we have, which in this case is 7. And let me do a little brief calculation. Hopefully you got the same number. Easy to make mistakes on these, by the way. They're rarely done by hand. They're almost always done in spreadsheets or computers because it's easy to mistype a piece of data. Hopefully I won't do that. 14, 16, 16, 17, 19, 27, 31. There we go. Divided by 7. Nice even number. That doesn't always happen. 20. There's my mean. The median is easy to do. This has 7 numbers, so I just go 1, 2, 3, 4, 5, 6, 7. I count in. It'll be the middle one, which is the 4th one. So it's just 17. And then the mode is also easy to see. It's the only repeated piece of data, which is the 16. So the mode is 16. Okay. I'm going to talk about when we get another piece of when we get one more piece of information or one more piece of information, definition, and then I'll talk about when do you use mean, median, mode, and why do you care what they actually are. Okay, the last data I'm going to use before we do a couple more problems is what's called another statistical measure. It's called an outlier. So an outlier is a piece of data that doesn't seem to fit, which is sometimes called an anomalous piece of data, or one that doesn't fit. Sometimes this shows up because you have a mistake when you collect data, especially in like a laboratory experiment. It's something that doesn't seem to fit. The distance is between this piece of data and another one is way larger. Like you're collecting a bunch of temperature data, it's all like 20, 21, 22, 25 degrees. Then suddenly you have one that's 100. Usually it means it's a mistake. You have to be careful not to throw them out, though. If you throw too many out, you basically skew the data and make the analysis incorrect. So let me give you an example of another data set, and we'll do the same. We'll do mean, median, mode with and without an outlier. So here's my data set: 16, 19, 21, 18, 18, 54, 20, 22, 23, and 17. It's a large data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. Comma separate them here. Okay, first thing you do again is always order them. In spreadsheet, you can do that with a simple key. And here I've actually got to go through and write them out. It looks like the smallest one is 16 again. Then it goes 17. There's a couple 18s. There's a 19, a 20 from over here, a 21, a 22, a 23, and finally a 54. Again, count them to make sure you've got the right numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. Okay, so before we go into mean, median, mode, one of these data pieces doesn't fit. I think most of us will see it just visually. It's the 54. How do you know that's an outlier? We don't know for certain, by the way. It might be a real piece of data, but most likely it's not, because the difference between these is all 1, 1, 1, 0, 1, 1, 1, 1, 1. They're all kind of 1 apart. And then this one is 31 bigger than 23. That's a sign that you collected something incorrectly. So what you generally do is you just throw it out and then use the other data to do your mean, median, mode. What I'm going to do is do both. I'm going to keep it in and I'm going to throw it out just to show you what the effect of it is. And this will also go into why you pick certain ways of calculating things, or which ones you pick, rather. So let's start with the mean. I'm going to add them all up, which is a lot of numbers, unfortunately. 16 plus 17 plus 2 18s plus 19 plus 20 plus 21 plus 22 plus 23. You probably can just look at this and tell the median. I'm not even trying to guess what the mean is, just looking at it. It looks like I guess it's 19 maybe, somewhere 18, 19. That's just my guess. And we got to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to throw the 54 out for the moment. And we get a mean without the outlier of 19.33. And then I'm going to do it with outlier. I'm just going to put that other piece of data into my original piece. And I'm also going to have to divide by 10 instead of 9, because there are now 10 pieces of data. And I get 22.8 with the outlier. Okay, median, again, I can count them. I'm going to do it without the outlier first. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data, which is an odd number, so it's just the fifth one that's the median, which is right there. 4 on that side, 4 on that side. And that means the median is 19. If I keep the pieces of data, the 54, there are 10 pieces of data, which means the median is now between 19 and 20, average of 19 and 20, or 19.5. The mode is 18, it looks like. It's the only repeated one in either case. Okay, so now let me talk about the effect of an outlier and which one you generally want to use in which circumstances. So first of all, the biggest skewed one was the mean. And the reason that is because I added 54 in, which is way bigger than the other numbers, and that pulled the mean up almost 3.5. Median was virtually unchanged, and the mode was unchanged. So the mean is most affected by outliers. In other words, it's the most impacted by mistakes. So generally, you don't want to use the mean. You still have some value, and especially for smaller data sets, it's important because the median kind of skews things. But if you have a very large data set, the median is actually generally the better number to use because it doesn't get skewed by making mistakes very easily. The middle number is still a middle number. If you happen to have a couple of pieces that are wrong, it's not really going to affect it very much. And the mode is completely unimpacted. Now, the only reason you don't use the mode for anything is it doesn't really tell you what the center is. It just tells you what's most repeated. So the mode, for example, in this case is 18. But if I had two 16s or something, you'd have the mode is 16. That's in no way the center. It's just the most repeated value. It's actually the far left of the numbers. So again, generally try to use median, although mean does have its values. Median does not have the effect of the outlier effect. And mode is generally just used not as really center tendency, but more as a, like if you're saying, I don't know, what's the most common shoe size in America? It's going to be the most commonly used. It doesn't matter if it's the left smallest or largest. It's going to be the one most commonly used, which I don't know what it is in America, probably size 7 for men, size 8. Okay, that's central tendency. Again, mean, median, mode, and outliers and the effect on those. We're now going to do another measure, a statistical measure, which is quartiles. And then we're going to use the quartiles for something else, which is to make what are called box and whisker charts, which are frequently used in the SAT. You may have seen these before as well. So we're going to define quartiles, and we're also going to define, to do that, we're going to have to define range. In fact, I probably should do that first. So range of a data set is just the difference between the largest and smallest values. All right, smallest to largest, the smallest and largest values. So basically it's saying, if I have a data piece, say it's going from 1 to blah, 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 to 95, the range of this data would be 94. That's the difference between 1 and 95. Range equals 94. Okay, now we're going to talk about quartiles, and what is called interquartile range. So the median divides the data in half, essentially. The quartile divides the data into 4 parts. The median will be the middle quartile. Then you have one that's at 25% of it, which is the first quartile, and then you have one that's at 75%, which is the third quartile. I'll give you some information on these in a moment. I have an example that'll explain it better. But let me give one more definition, which is called the interquartile range. The interquartile range is the difference between the first and third quartiles. So this is used to basically determine how wide ranging the data, how spread out it is. If you have a very small interquartile range, the data is all clustered in the middle, and that's generally a good thing. It means you're collecting data consistently. If you have a really wide interquartile range, it means that the data is all over the place, and therefore your conclusions you take from that are probably unreliable. Okay, let me give an example now. I'm just going to pick up a random data set, again, of, let's do 12 items. 1, 3, 5. I'm going to put them in order this way just so it makes it, so I don't have to reorder them. 8, 12, 16, 18, 27. And let's do 3 more. 30, 31, 35. Okay. That is 12 pieces of data if I did it right. 3, 6, 9, 12. 3, 6, 9, 12. Yes, 12 pieces of data. So first of all, let's go through each of these in turn. I'm going to start with the range. The range is 35 minus 1, or 34. It's the entire extent or range of the data. You go from 1 to 35. which is a total of 34 spots. The quartiles, you have 3 quartiles. You have what's called the first quartile, the median or second quartile, which is also the median, and the third quartile. Quartile means quarter, so this is 25%, 50%, and 75%. Okay, so start with the median. The median is the middle again. There's 12 pieces of data, which is even, so it's going to be between the 2 pieces. 1, 2, 3, 4, 5, 6, 7. It's right between here. So that median is therefore 12 plus 16, the average of 12 and 16, which is 14. The first quartile, you're now going to take this data from the median to here and get the middle of that. So there's 6 pieces of data there between the start and the median. So you got to find the one that's between 3 and 4, which is 5 and 7. Again, it's not even, just like the median. You have 6 pieces of data. See, it's halfway between those two, or 6, halfway between 5 and 7. And then the third quartile is halfway between 27 and 30. Again, 6 pieces of data. It's between the third and the fourth, between the 27 and the 30, which is 28 and a half. Okay, so again, just some definitions. Range is the difference between the smallest and largest values. Quartile is basically splitting up the data into quarters. And the interquartile range, I should write that as well in here. Quartile range is the difference between the third and the first quartiles. In this case, 28.5 minus 6, or 22.5. So in this case, 22.5 is pretty large compared to the total range of 34, which means the data is pretty spread out. That's because I just randomly do it out there. Most of the data you want should be collected more centrally. If you're trying to find something that's useful out of this, this is essentially a random data set, which this indicates, because 22.5 is 2/3 of 34, and it should be really, at worst, half, since the range is the entire amount, and this is supposed to be half of it, just the middle half. So that's a pretty spread out piece of data. Okay, now we're going to use this data to create what's called a box and whisker chart. And in fact, I may try to write this out here and just use the data itself. So actually, it's right at the top here. Rather than redo this whole thing and write a whole new section of data, I think I'm just going to use this data. Okay, so a box and whisker chart basically is a summary level of all this information. And here's how you draw it. You draw your data on a line, which goes, in this case, it doesn't matter, I'll make it from 0 to 36. Actually, I'll make it from 1 to 35. 1 to 35. That's your entire range. If I want to keep going, we'll go to 0 here. This can keep going, there are arrows. You basically put the first, second, third quartile data on a box. In this case, it goes from 6, 79 pixels, let's say it's about 6. I'll put this information on there. And then you put a box indicating the quartiles, like so. This is the Q1 box. Sorry, this is on this side, Q1. This is median, or Q2. And this is Q3. Those are the 3 pieces of information I collected. You can also pull the range easily off there. 35 minus 1 is right there, 34. And then you put the whiskers, these are the boxes, you put the whiskers out to the total range. This goes out to 35 and 1. And there we go, that's a summary of the data. You pull all this stuff out of there. You can pull out the range, 1 to 35. You can pull out the quartiles. You can do the interquartile range if you want. It's right here, 28.5 minus 6, the 22.5. You have the median. And it all fits in one summary level picture. Okay, I'm going to have you guys do one now. I'm going to erase all of this, so you write that down as an example. You may need to pause there. I'm going to write another data set, a little smaller one, so I don't have to do quite as much analysis. Erase it all here. Okay, I'm going to give you a data set again. 1, 2, Let's make it a little more central so you see what it means if it's tighter. 1, 4, 5, 5, 5. And let me paste the data we should use. Let's use 6, 6, 7, 9, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces of data. 1, 4, 5, 5, 5, 6, 6, 7, 9, 10. Looks a little more concentrated. So what I want you to do is go through and find, let's find the range, the Q1, Q2, which is again the median, and the Q3, the interquartile range, and why don't we find the mean as well while we're at it, to summarize the other stuff, and also the mode. Here we go. Bunches of different stuff there. 4, 5, 6, 7 pieces of information you need to find. Okay, pause the video there and try to go through those. Okay, if you're back, let's start with the range. The range is just 10 minus 1, or 9. You have 10 pieces of data, even numbers, you have to count in. It'll be between the, sorry for this, we're doing the median first. And 9, 11, 6. It's right between the 5 and the 6, right? Here's the median. Between the 5 and the 6. 4 pieces on each side. So that's 5.5. Q1, this is the median right there. Q1 is, actually it's 5 pieces of data, so the median is just the 5. It's the third one out of the 5. On this side is the third one out of the 5 again, which is the 7. So there we go. 5, 5.5, 7. And then the interquartile range is the difference between 7 and 5, which is just 2. The mean, I'm going to have to calculate. The mode I can actually just see. I've got 3 5s, that's it, it's 5. The mean I'm going to have to calculate. 1 plus 4 plus 5 plus 5 plus 5 plus 6 plus 6 plus 7 plus 9 plus 10. And we'll divide that by how many numbers? 10. 5.8. Okay, so what does this all mean if you look at it? So first of all, the interquartile range is very small relative to the total range. So 2 out of 9. 50% of the data is within 2 of the median. So it's a very tight data set. And that's because I specifically wrote most of the data around the middle, 5s and 6s. And you can see that's a much tighter data set. What are the pieces of information that's useful out of this? The mean is not very much different than the median, which also means there's not probably any outliers on it. The data was all kind of normal. You can see like 57 out here. Most commonly used is 5. Single mode. There's only 5s. Okay, now I'm going to, last thing we do on this is I'm going to have you draw a box and whisker chart. So pause the video there now and just use that data to draw a box and whisker. Okay, if you're back, we're going to go from, and I'll just mark it 0 to 10. No, let's make it 0 to 11 just to make it a little bigger than the data set. The first data set is at 1, beta piece is at 1, the last one's at 10. Now I'm going to put my median in, which is 5.5. And Q1 is 5, basically right next to it. Q3 is a little bit further over, 7. Q1, Q2, and Q3. And there we go. So this is a much better, hopefully you got that or something similar to it. This is a much better data distribution, more useful data. Most of the data is in the middle. The box is much smaller than the whiskers. So you want it to be concentrated in. Notice it's a little skewed right, the data. The Q3 is wider than, Q2 to Q3 is wider than the Q2 to Q1. That means the data is kind of skewed to the right. Okay. That is, we have one more concept to do and then we'll stop. We're going to do what is called percentiles now. So I'm going to put that up first. This is the last statistical measure we're going to do today. So percentile is a measure, and it's measured from 0 to 100%, indicating the value below which a given percentage of observations in a group fall. So again, I'll go through this in, so you measure there. So percentile is measured between 0 and 100, and it indicating the value between which a given percentage of observations in a group fall. So let me give you an example that's very relevant to you. If you are taking the SAT, you'll get a metric back which will say you're in the 65th percentile. It'll say 65th percentile, or it'll say percentile, and then below that it'll say 65%. Percentile. What that means is 35%, 100 minus 65, have higher scores than you, and 65% have lower scores than you. So it's a much more exact measure. Think of it as quartiles or medians and things like that. Median's 50%. Quartile is 25, 50, or 75, depending on what's Q1, Q2, or 3. This is just much more granular. It tells you within a percent, or you can do decimals, where you stand within the entire data set. Okay, that is it. So a bunch of terms we had to remember there. I'll just write them down first as a summary, and then give you the homework. So we had central tendency measures, which are mean, median, mode. Most often you want to use median, although mean is actually frequently used as well. And then we had the idea of an outlier, which is a piece of data generally you want to throw out, which isn't within, it's basically a mistake of the collection. Make sure you're not throwing out data because it's real data, though. Usually, sometimes outliers are actually real. Next we had quartile, which was breaking the data into quarters instead of halves like median does. Range, which was the total set of all data. And interquartile range, interquartile range, which is the distance between Q3 and Q1. So it's a measure of how concentrated the data is in the middle, how accurately you're collecting how good the data is. And then finally we had the box and whisker chart, which is just a illustrative way to show quartiles, ranges, interquartile ranges, medians on the same chart. And you can tell from it if the boxes are small relative to the whiskers, it's a good well collected data. If it's wide, it probably means the data is pretty useless. Okay, and the last term we had was percentile, which is just, again, measuring something like quartile, except it's just much more granular. You're doing it between 0 and 100, and this instead of by quarters or by halves. Okay, that's it. The homework for Algebra 2 is homework number 22, and that'll be due in a couple of days. All right, that's it.